Hello there and welcome back to the Science Sleepy Minds. Tonight, you're gliding silently through the void, the inky, freezing, reality-warping space that lies between galaxies. Far from the cozy confines of Earth, there's no up, no down, just you. Floating serenely in a dark so ancient it makes your home planet look like a newborn blinking in the light. Ahead of you, a spiral galaxy, graceful, glowing, full of stars like sunspots on a cosmic canvas. But there's a problem. You can already feel it in your bones, in the slow inward pull that makes every atom in your body want to turn around. This galaxy is too close. It's falling into something it cannot escape from. You probably won't survive this. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, drop your location and local time in the comments. I love seeing where and when you're listening. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You are staring at a galaxy. Let's call it one of the beautiful, well-behaved spiral ones. The kind with graceful, winding arms full of blue giants, twinkling clusters, and interstellar gas that gives birth to stars. It's somewhere between 100,000 to 200,000 light years across, spinning lazily in the dark like a frisbee thrown by a god. From your vantage point, it looks safe, balanced, alive. But space is not a safe place. This galaxy isn't isolated. It's been drifting, quietly, imperceptibly, into the gravity well of a lurking monster. And I do mean monster, a supermassive black hole billions of times the mass of our sun, sitting like a cosmic drain, invisible until it's far, far too late. It's not the galaxy's black hole. We'll get to that one. This is an external black hole, one that was probably part of a larger galaxy cluster. Maybe it formed at the core of a now merged system. Or maybe, as some fringe theories suggest, it's a primordial giant from the earliest epochs of the universe, before galaxies even properly existed. The spiral galaxy doesn't fall in all at once. The process is more like a cosmic Greek tragedy, slow, inevitable, and weirdly beautiful. From your ghostly perspective, you begin to notice something odd about the galaxy's outer edges. Stars are subtly shifting in their orbits, like dancers taking one final bow before stepping off the stage. At first, you think it's just a trick of light. But no, it's the beginning of unbinding. Gravity, that patient sculptor of all things, is now the executioner. The stars on the galaxy's far edge are starting to peel away. Not in a dramatic Star Wars explosion kind of way. No, they just drift. Pulled into looping thread-like arcs, some stretch into faint tidal tails, those long luminous trails of stars you sometimes see in galactic merger photos. They're not just pretty, they're screams frozen in time. These stars have been stripped from their home, and now they wander. This phenomenon isn't hypothetical. Astronomers have watched real galaxies in the Virgo and Coma clusters undergo exactly this kind of unravelling. A process of slow death via gravity, where the galaxy is tidally disrupted over millions of years. The brightest central regions stay intact, for a while, but the periphery, that's where the black hole starts its feast. Historians of the cosmos, yes, they exist, still argue whether such destructive interactions happened more often in the early universe, or are ramping up now as galaxies cluster closer together. There's even debate on whether some ultra-diffuse galaxies we found are survivors of such encounters, stripped bare, but still technically alive. Meanwhile, back in our sleepy spiral galaxy, you watch the glow of the outskirts dim. Star systems vanish from view, dust and gas spiral outward like smoke blown across a black velvet sky. There's a kind of melancholy here, isn't there? This isn't an explosion. It's erosion, cosmic erosion stretched across epochs. You float closer to the center. The galactic core still pulses with energy. It's fighting back in a sense. Gravity is local. The inner part of the galaxy is still tightly bound to itself, but the balance has been upset. Stars that once danced in near-perfect orbits now find their paths wobbling, nudged ever so slightly by the invisible influence of that black hole's immense pull. The galaxy has become lopsided, tilted. It's no longer the serene spiral it once was. Now it's a distorted, struggling swimmer caught in the whirlpool. A random but oddly charming fact. In some simulations, galaxies that fall into black holes or much larger galaxies tend to trail behind small, loyal companion galaxies, like cosmic sidekicks that get dragged along into oblivion. The galactic version of Thelma and Louise, really. You spot one now, a tiny satellite galaxy, barely visible, trying to follow its parent. Poor thing. No one told it that loyalty in space rarely ends well. As you drift further inward, you notice something eerie. The very structure of the galaxy seems to be unraveling. It's no longer just about stars being pulled out. The spiral arms are beginning to twist. Not artistically, but like they're being kneaded, pulled and folded. The entire gravitational balance of the galaxy is under attack, and this is just the beginning. This galaxy is now what astrophysicists call a disrupted system. It still exists technically, but not for long. From here on out, the spiral won't hold. Over the next few million years, a blink for space, an eternity for you, this galaxy will transform into something unrecognizable, a smear of stars, a ghost, and eventually, little more than a curious wrinkle in the cosmic microwave background. You're still floating there, but even you can feel it. The deeper pull, the central region of the black hole's gravity is starting to win. The game isn't over, but the end is scripted, and the spiral, it's just the opening act. You're still drifting in that silence, the kind of quiet you can only get in the vacuum between galaxies, where even light seems reluctant to stick around. Behind you, the spiral galaxy's beautiful shape continues to warp, no longer the tidy pinwheel it used to be, and ahead, that same slow, hungry pull. The black hole doesn't reach out like a monster in a horror movie. It doesn't need to. Its gravity is enough. Right now, you're watching something remarkable. The galaxy's outer layers being unstitched star by star like sequins falling from a gown in reverse motion. The cause? Tidal forces. Now, you've probably heard the term tidal forces tossed around in sci-fi shows. Spoiler, it's not just a fancy term for space ripples. It's what happens when gravity isn't the same from one end of an object to the other. Your feet feel a different gravitational pull than your head, assuming you still have feet, when you're getting too close to a black hole. For something as massive as a galaxy, this force acts on a cosmic scale. The side of the galaxy closer to the black hole feels a stronger tug than the far side. Over time, that differential stretches the whole system. Imagine this. Stars once on the fringe now find themselves flung into looping arcs that stretch thousands of light years. Others, trapped just enough, spiral inward. These are the famous tidal tails you see in Hubble images, celestial threads marking the slow undoing of galactic cohesion. Not just beautiful, but terrifying if you think about it too long. Historians of the cosmos, the kind with access to billion-dollar telescopes and scary math skills, have documented dozens of these interactions. In particular, the antennae galaxies, which are colliding rather than being swallowed, showcase the exact kind of tidal features you're seeing now. It's a preview of galactic disassembly, live, in high-res colour. But here's the weird part. Not all galaxies fall apart the same way. Some seem to fight back. That's because of dark matter, the invisible scaffolding that holds galaxies together. We don't know what it is. No one does. Could be weakly interacting particles, Could be something completely wild like gravity acting differently at large scales. But whatever it is, it matters. A lot. Galaxies aren't just pretty disks of stars. They're embedded in giant invisible halos of dark matter, like jelly inside a donut you can't see but somehow still taste. As the galaxy you're watching is pulled in, its dark matter halo gets tugged at too. But here's the kicker. The dark matter doesn't behave quite like the regular matter. It doesn't radiate. It doesn't collide. It just sort of flows. That means the galaxy's fate, how quickly it's shredded, whether it can hold its shape at all, depends not just on its stars but on this mysterious dark glue. Some galaxies fall in and get completely pulverized, leaving behind only scattered stars and a mournful gravitational signature. Others? They survive, twisted and scarred, but intact at their core. The difference often lies in how much dark matter they had clinging to them and how tightly it held. It's still debated whether galaxies with heavier dark matter halos can effectively shield their cores during these interactions. Some simulations suggest yes, others not so much. The science is fuzzy, like trying to study wind by looking at scattered leaves. And now you're seeing that in action. The galaxy in front of you is beginning to show signs of structural collapse. The arms are no longer spiraling in a graceful curl. They're twisting awkwardly, some stars forming strange new clumps, others simply gone. You spot what used to be a star-forming region, bright blue and chaotic, 100,000 solar masses worth of new suns. It's dimming now, like a campfire left unattended. But something else is happening too. Deep inside the centre of the galaxy, where the gravitational pull is strongest, stars aren't fleeing. In fact, they're falling inward. Their orbits, once neat ellipses, are becoming chaotic, spiralling closer to the galactic core. Why? Because the balance between centrifugal force and gravity, the thing that keeps spiral galaxies spiraling, is breaking down. Here's a fun, unnerving fact. If you were on a planet orbiting one of those stars, the sky would look increasingly strange. The familiar constellations would warp over millennia. Some stars would vanish entirely. Others would appear in your sky with no warning, flung in from other parts of the galaxy. It'd be like watching your night sky have a midlife crisis. This breakdown is part of a phenomenon astrophysicists call secular evolution. Basically, the slow change in a galaxy's structure over time, driven by internal forces. But in this case, it's like the galaxy has been shoved down the stairs instead of gently aging. Oddly enough, this process isn't entirely destructive. It sets the stage for future events. As stars fall inward, they bring with them momentum, heat, and gravitational chaos. This can feed central black holes, trigger starbursts, and even form bizarre new structures like pseudo-bulges, dense, bright clumps that look like galactic cores, but aren't. Cosmic imposters, if you will. You pass through one of the spiral arms now, or what's left of it. The stars here are scattered, like someone knocked over a cosmic box of thumbtacks. Dust clouds linger in weird, stretched-out shapes. Some of them are glowing faintly, heated by nearby stars that haven't figured out the galaxy is ending yet. You float past one such star, a bloated red giant, ancient and unaware, puffing its outer layers into the cold. It'll be gone soon, swallowed or flung into nowhere, a victim of galactic drift. The closer you get to the centre, the more you notice that something is very, very wrong. It's not just distortion anymore, it's disorientation. You can't tell where the galactic plane ends or begins. The black hole's gravitational influence is starting to bend space itself. The stars seem to flicker and swirl, their paths less like orbits and more like whirlpools. This is only the middle stage. The galaxy hasn't been swallowed yet, but it's no longer whole. Its identity is breaking apart. Spiral arms lost, stars fleeing, core swelling unnaturally. It's not a spiral anymore. Not a sphere, not anything you can name. And through it all, the black hole waits. Patient, silent, powerful. You've crossed the boundary now. The galaxy has officially passed the point of no return. You're no longer hovering at the gentle fringes. That was the scenic route, the part where stars drifted and spiral arms unfurled like taffy. Now you're getting closer to the true engine of destruction. But even here, amid the chaos, something invisible is shaping everything around you. You don't see it, you can't feel it, but without it, none of this would be happening the way it is. It's dark matter's time to shine, figuratively speaking. You glide silently through the galactic interior, and while it may look like a swirling mess of stars, dust, and doomed hopes, there's another layer to this, the dark matter halo. Every galaxy you've ever heard of, our Milky Way included, sits inside one. Picture it as an enormous spherical cushion of mass you can't see, but that's always been there, holding everything together like the world's most antisocial safety net. Right now, that safety net is being stretched and tested. Dark matter doesn't clump and swirl like ordinary matter. It doesn't form stars or glow or make cool nebulae. But it does one crucial thing. It keeps galaxies from flying apart. In fact, without it, the outer stars of any galaxy would just drift away, moving too fast to be held in by gravity alone. We know this because when astronomers first measured galaxy rotation curves, how far stars orbit at various distances from the centre, they realised something weird. The stars at the edges were moving too fast. Way too fast, like, this shouldn't be physically possible fast. Unless there was more mass than we could see. Dark matter. In your current view, the spiral galaxy falling into the black hole is surrounded by this dark cocoon. Or it was. The gravitational disruption caused by the external black hole isn't just pulling at the luminous stars, it's pulling at the entire halo. And the way dark matter reacts, well, that's still a hot debate. Some researchers believe the dark matter halo deforms, stretching into an elongated shape that trails behind like an invisible cape. Others suggest the halo sloshes. Yes, that's the technical term. Sloshes back and forth as the galaxy is jerked around by larger gravitational forces. Think of it like cosmic jello getting jiggled in slow motion. Historians and cosmologists continue to argue whether dark matter halos recover after such distortions, or if they're permanently reshaped. Some simulations show that once disturbed, these halos never really settle back down. Others hint that they relax over time, like a messy room after a very patient cleanup session. Meanwhile, you're watching the consequences unfold. The dark matter halo, once spherical, now looks subtly stretched. Not that you can see it directly, but you can see its effect on the stars. Their motions are odd. The symmetry is gone. Some stars are orbiting too fast, others too slow. The normal gravitational scaffolding that made spiral arms and central bulges work like clockwork. It's gone lopsided. This kind of dark matter distortion often leads to asymmetric collapse. Parts of the galaxy fall inward faster than others. Some regions get compressed, almost like a black hole appetizer. Other regions lag behind, pulled into tidal tails or flung into intergalactic space. And then there's the really strange part. As the galaxy falls in, the black hole's own dark matter halo interacts with the incoming one. It's like watching two invisible clouds of gravity overlapping. No sparks, no explosions, just a quiet war of mass and momentum. There's fringe speculation, fun but very unproven, that these halo interactions could produce gravitational lensing echoes, strange distortions in how we observe distant light sources. Some scientists are trying to detect these to map the shapes of interacting halos. It's basically the universe's version of sonar. Back in your current location, another weird thing is happening. The stellar halo, those old dim stars floating far above and below the galactic plane, starts to respond. These stars were already loosely bound. Many of them are billions of years old, long past their prime. They've been drifting in solitude, barely influenced by the spiral chaos below. But now they're being perturbed. A few get ejected, like completely, into the void. These stars become rogue intergalactic wanderers, drifting alone for eternity. Others fall inward, their lazy orbits redirected by subtle, gravitational nudges from both the galaxy's own halo and the external black hole's pull. They'll die in strange new places, possibly lighting up as novae or quietly fading out in solitude. There's something poetically sad about these stars, born in a galaxy that's slowly dying, flung out into nowhere. But on the plus side, they won't pay taxes. As you sink deeper into the galactic core, you feel the weight of this invisible war. The stars you pass are jittery, their paths perturbed by unseen hands. The central mass of the galaxy, a dense cluster of old stars and tightly packed matter, is starting to swell. Not because it's gaining mass, not yet, but because everything else is being funneled toward it. You float above the disk now, looking down on what's left. The spiral pattern is smeared, like someone dragged their fingers through wet paint. Dust lanes that once formed neat arcs are now jagged, torn, stretched. You can almost hear the silent scream. Below you, the galactic bulge shudders faintly. The black hole is pulling harder, but for now, the dark matter halo is still resisting, just barely. Another quirky side note for you. In some simulations, galaxies with very dense, compact halos can experience something called core stalling. It's where the central black hole doesn't fully devour the galaxy's centre because the gravitational interactions with dark matter slow its inward spiral. Like a traffic jam on the road to destruction. Will that happen here? Probably not. You can tell by the way the stars are moving. It's all flowing inward, nothing stalling. But in other galaxies, this may have saved their cores from total collapse. A weird little mercy from the cosmos. You pause if floating observers can pause and look around. You're standing in the result of billions of years of structure, collapsing in a slow-motion ballet choreographed by invisible matter. It's not dramatic. There's no sudden bang, just movement, swirling, warping, unbinding. And the dark matter, still holding the reins, for now. But remember, it can only resist so much. The gravity of the black hole isn't just pulling stars, it's warping space-time itself. And that, my sleepy traveller, is where things get stranger. You drift now in the thick of it, no longer skimming the edges or observing from a comfortable remove. The spiral galaxy is unravelling around you, its arms no longer spiralling but flailing, flaring and fragmenting. You once could trace their gentle arcs like ripples in a pond. Now they look like a spilled bowl of spaghetti, tugged in all directions by forces it never evolved to face. The centrifugal balance, the delicate dance between gravitational pull and outward momentum, is failing. Like a carousel coming off its axis, the stars are no longer keeping their places. Entire regions of the galaxy begin to shear away. Some stars spiral inward, flung toward the black hole in tighter and tighter loops, while others are unceremoniously ejected outward, tossed into intergalactic space. You can almost imagine them muttering, "Well, this wasn't on the travel brochure." The spiral arms, those gorgeous ribbons of star birth and glowing gas, were never permanent. Not really. They're more like traffic jams, temporary density waves where stars and gas crowd together before moving on. But here, the traffic pattern has been hijacked. Gravity from the approaching black hole, the warping influence of competing tidal forces, and the destabilizing dark matter interactions you just passed through. It's too much. The arms can't hold. There's a strange beauty to their destruction. Long arcs of stars stretch across thousands of light years, still faintly glowing, still holding on to a memory of the order. but they're drifting now, no longer part of a living, breathing galaxy, more like glowing fossils, streaks of former symmetry suspended in space. You drift closer to the remains of one arm and pass by a young cluster of blue-white stars. They're burning hot and fast, oblivious to the galactic collapse unfolding around them. In a few million years, long before the black hole finishes its meal, they'll go supernova, but their light won't reach anyone, not anymore. That's the thing about galactic collapse. It doesn't just change orbits, it changes futures. The gravitational disruption wreaks havoc on star formation, especially in the arms where most new stars are born. The disruption pulls apart molecular clouds, scatters the dense gas needed for protostars to condense. The lights don't just go out, they never get a chance to turn on. You may find this oddly comforting. Even in the middle of destruction, some structures hold for a while. Clumps of stars orbiting as globular clusters remain gravitationally bound. They're dense enough to survive the galactic unravelling, at least for now. Some get flung into wide orbits around the galactic remains, like ancient sentinels circling a battlefield. Others will fall inward, straight into the waiting jaws of the black hole. Historians, okay, astrophysicists, but they do moonlight as cosmic archaeologists, have discovered real-life galactic remains that tell this exact story. One example, the Sagittarius dwarf galaxy, which is currently being slowly digested by our own Milky Way. Its stars are smeared across our sky in long tidal streams, an echo of a spiral arm that once was, kind of like the ghost of a galaxy that didn't know when to leave the party. And you, in this quiet moment, are surrounded by such ghosts. You pass through a gap where an arm used to be. The density is thinner here now. You can see stars from the opposing side of the galaxy, twinkling in a distant arc, as though they're reaching out to one another across a fracture line. Another oddity catches your attention. There's a twisting, glowing thread spiraling inward toward the galactic core. It's not a spiral arm. It's something worse. It's a gravitational funnel, a stream of gas and stars being directly siphoned into the black hole's growing influence. Like a cosmic whirlpool, it slurps matter inward with eerie steadiness. In these streams, things start to accelerate. Gravity pulls harder. The once sedate paths of orbiting stars turn erratic. The spiral galaxy's core, already under pressure, is being fed more mass than it can comfortably process. And that's where we move next, the central chaos. But before we leave the arms behind, take a moment. Remember how the galaxy looked from afar? Symmetrical, peaceful, the kind of spiral that gets printed on educational posters and desktop wallpapers. That shape wasn't just for show, it was an identity. And now, it's gone. The galaxy is no longer recognizable. It doesn't have arms. It doesn't have a balanced disk. What remains is a warped, chaotic structure. Astronomers sometimes call these peculiar galaxies, which is frankly an understatement. They're the aftermaths of destruction, where you can still see what once was, but only barely. Like a painting that someone tried to erase and redraw at the same time. And yes, there's a kind of poetry to the timing. This destruction doesn't happen quickly. It takes millions of years, time enough for stars to be born, shine brightly and die, all while their host galaxy is being unraveled like a sweater in reverse. You float now just above the galactic midplane, where things used to be tidy and flat. It's a mess. Stars of every size and age are out of position. You see a rogue blue giant, a star that probably formed deep in the spiral arm, now awkwardly flying solo through a region once reserved for old, redder stars. It's like finding a punk rock drummer at a knitting convention, very much not where they're supposed to be. These odd redistributions can lead to strange results, new patterns of star formation, bizarre gravitational groupings, and even the formation of bars, long linear structures of stars and gas that form across the galaxy's centre as it tries to stabilize in its last gasps. One school of thought says that these bars are a transitional phase, a way for the galaxy to rechannel its momentum and settle into a more elliptical shape. Another school argues they're just scars, temporary features that will collapse as the black hole finishes its work. Nobody really knows. It's hard to study something that takes 1 billion years to happen. You're now following one of these nascent bars curving inward toward the core. It's not smooth, it's bumpy, irregular. Stars don't move in unison anymore. They're out of sync, like dancers who've all lost the beat. Some are on inward spirals, others loop erratically, trapped in gravitational eddies. And as you near the core, you can finally feel the scale of what's coming. The black hole's presence is no longer just a mathematical tug. It's a distortion in reality, a deepening curve in the cosmic floor. The arms are gone, the disk is warping, the center is stirring. Something is about to awaken. The deeper you drift, the stranger the motion becomes. You're now weaving through the inner regions of the dying galaxy, where order used to reign. Once upon a time, roughly a few 100 million years ago, give or take, this part of the galaxy was the definition of stability. A bulge of stars, gas and dust in tight elliptical orbits, glowing faintly golden in contrast to the young blue stars out in the spiral arms. It was warm, predictable, a place where gravity kept things mostly in line. Now it's like watching a chandelier fall in slow motion. Everything is still attached technically, but nothing is where it's supposed to be. The star clusters are the first things you notice. These are tightly packed groups of hundreds of thousands of stars, all born from the same cloud. In a healthy galaxy, they orbit calmly near the center, held together by their mutual gravity and a shared history. But now, they're panicking. Yes, panicking, as much as inanimate collections of suns can panic. Some of these clusters are being flung outward by the increasingly lopsided gravitational forces, shot out like cannonballs into random directions. Others spiral inward at steep angles, caught in the growing gravitational sinkhole of the galactic core. Their orbits are no longer simple ellipses. They've become twisted figure eights, spirals, wild oscillations that physicists would lovingly describe as chaotic and extremely non-Newtonian. You float beside one now, passing through the outskirts of a glittering cluster where the stars are so densely packed it's like being inside a disco ball made of hydrogen fusion. One moment you're bathed in the soft gold of aging red giants, the next moment scorched by a close call with a massive blue-white supergiant. There's no air to carry the sound, but if there were, this place would hum with gravitational tension. Clusters like these don't all survive the descent. As they fall inward, tidal forces begin to stretch them, a prelude to disintegration. If the pull is uneven across the cluster, and it almost always is, then the cluster unbinds. Stars peel off, leaving a ghost trail behind them, like a dandelion being pulled apart by invisible fingers. Some lucky clusters stabilize into strange new orbits around the central mass. Others become streams, long trails of stars that stretch through the galaxy like comet tails, telling silent stories of where they came from and how violently they were pulled apart. Astronomers today have catalogued real examples of these tidal streams in our own Milky Way. One of the most famous, the GD1 stream, is thought to be the remains of a shredded star cluster or dwarf galaxy. It snakes across our sky like a fossil trail, a reminder that galactic cannibalism isn't just a theory, it's a recurring event, and it's happening again right now in front of you. You pass through another region and notice something strange. There are stars moving the wrong way, not just odd orbits, complete reversals, counter-rotation. These stars didn't start here. They may have been part of a merging satellite galaxy, or perhaps torn from one of those panic-stricken clusters. Their presence disrupts the motion of the rest. adding friction, complexity, and instability to an already wobbling system. It's like adding a few dozen rogue Roombas to an already chaotic dance floor. Things start bumping into each other, hard. This internal turmoil isn't just academic. The disordered motion accelerates the destruction. It helps transfer angular momentum outward, allowing more stars and clusters to fall inward. The center gets denser and more dangerous. But not everything falls in. Some objects, some stars, some clusters actually escape. Like proper escape velocity, gone for good escape. The momentum they gain as they slingshot past the black hole allows them to break free of the galaxy's gravity entirely. These become hypervelocity stars travelling at millions of kilometers per hour through intergalactic space. Some astronomers believe we've detected a few of these in our own galactic neighbourhood, like fireworks from ancient forgotten collisions. Imagine that. You're born in a calm star cluster, spend billions of years orbiting peacefully, and then, one day, gravity slings you out of your galaxy and into the void forever. Kind of rude. And yet that's how the universe plays its game. You begin to notice the black hole's growing influence in more subtle ways now. Light from nearby stars bends unnaturally. There's no event horizon yet in sight. You're still outside that fatal boundary, but reality is starting to curve. Space itself feels warped. Distances no longer behave intuitively. A cluster that looks close takes longer to reach. One that seems far zips by unexpectedly. The geometry is off. This, by the way, is a preview of relativistic gravity at work. As you approach the black hole's domain, Newtonian physics, those tidy rules you learned in school, start to crack. The equations no longer add up. Time itself begins to dilate. It's not enough to notice yet, but the distortion is there, curling at the edges like heat rising from asphalt. Closer to the core, you spot something massive moving fast, far too fast for a star. It's the galaxy's central black hole, the one it was born with, a supermassive black hole, likely millions or even billions of times the mass of our sun. And it's not just sitting there, it's moving. That's right. Black holes move, especially during mergers. This one is in the process of migrating toward the invading black hole that triggered all this chaos. The two are spiraling toward each other slowly, surrounded by an entourage of stars and gas. Eventually they'll collide, but for now they orbit each other like warlords eyeing a battlefield, distorting the space around them and stirring the inner galaxy into a violent stew of gravity, friction, and momentum. That will be a spectacular event, but not yet. For now, you're watching the gathering of forces. The star clusters around you are dwindling. The density near the core is increasing. There are more rogue stars here, more high-energy orbits, more chaos in every direction. The galaxy is losing shape, losing memory, losing definition. It used to be a spiral, now it's becoming something else. You drift now through the eye of the storm where the gravity is thick enough to feel like a pressure on your chest, if you had a chest or lungs or a body not immune to the total lack of time and air. But you don't, so you keep floating, quiet as the light that bends around you. Ahead, two monsters circle. They're not growling, not snarling, not throwing sparks like you might expect. Instead, they orbit each other in slow, menacing silence, like ancient statues spinning on a turntable. One is the black hole that belongs to the galaxy you've followed into destruction. The other is the interloper, the one whose gravity started this whole mess. A bigger one, hungrier, possibly older. They are supermassive black holes and they are heading straight for each other. You've heard the phrase, when black holes collide, and now you're about to witness it. But don't expect Hollywood fireworks, no flashy collision, no shockwave you could surf. This is an event measured in millions of years, in distortions of space-time, in the soft groaning of the universe's deepest foundations. Right now, the two black holes are in the inspiral phase. That's a lovely term for something absolutely horrifying. They're not touching yet, but they're interacting, spiraling inward, shedding angular momentum with every pass, drawing in stars, gas, and light like competing vacuum cleaners. It's a kind of cosmic mating dance, but one where the floor keeps breaking and the ceiling folds in on itself. Stars near this binary are in grave danger. Some are flung out at incredible speeds, ejected entirely from the galaxy in what's called the gravitational slingshot effect. Others are caught in the death spiral, pulled in closer and closer until they either fall into the black holes or are ripped apart in a spectacular and final show of astrophysical drama. This area becomes what scientists call a loss cone, which, despite sounding like a disappointing ice cream flavour, is actually a region of space where any object entering is guaranteed to be lost to the black holes. Gas clouds, star clusters, whole solar systems. If their paths intersect this zone, they don't come back. And it gets worse. As the two black holes spiral inward, their gravitational fields begin to interfere with each other in non-linear ways. Space-time here doesn't behave. You look across a field of stars and see them ripple, blur, split. Light bends around the dancing monsters, creating false images and distortions, like gravitational mirages. You're no longer sure how far anything is. Direction is a suggestion at best. This isn't chaos in the usual sense, it's relativistic instability. No tidy orbits, no Newtonian paths, just motion dictated by the insane curvature of space. You're watching a war in the fabric of reality, and it's quiet. Historians still argue whether this moment, this phase of galactic merging, is the most energetic period in a galaxy's lifetime. Some say yes. It triggers starbursts, feeds the black holes, and stirs the pot like nothing else. Others claim it's just a phase, one that most galaxies endure and move on from, quietly remaking themselves in the aftermath. But for the galaxy you're in, there's no going back. The core is breaking. The stellar orbits are being rewritten. The future is no longer spiral or elliptical. It's undefined. You drift closer, and now you can see the accretion zones around each black hole. These aren't event horizons yet. You're not that close, but the glowing disks of matter swirling just outside are breathtaking. Gas and dust heated to millions of degrees spiral inward at relativistic speeds, lighting up the dark like halos on fire. You see jets shooting out from one of them, narrow beams of high-energy particles launched from the magnetic chaos just outside the event horizon. These are relativistic jets, and they can stretch for thousands of light years, scorching everything in their path. Fun cosmic tidbit: scientists still don't fully understand how these jets form. Magnetic fields, rotation, pressure, geometry, it's all involved. But the full recipe remains elusive. The universe doesn't give up all its secrets that easily. You watch as one of these jets slices through a lingering gas cloud. The cloud flares, then dissipates. That cloud would have been raw material for new stars. Instead, it's now hot plasma heading outward at near the speed of light. The galaxy's future is bleeding away in luminous streaks, but for all this violence, the final collision of the two black holes is still a way off. They're spiraling closer, yes, but slowly. Very slowly. Even at this stage, millions of years in, they may take millions more to truly merge. It's a cosmic slow burn, a drawn-out prelude to an event that will briefly become the loudest thing in the universe. And by loud, I mean gravitationally loud. When these two black holes finally merge, they will release a storm of gravitational waves, ripples in the fabric of space-time that radiate outward at the speed of light. These waves won't make sound per se, but if you had a detector sensitive enough, like LISA, the proposed space-based gravitational wave observatory, you'd hear them as chirps in frequency and amplitude. The final moments of the merger would ring through the cosmos like a deep fading bell. Right now, though, it's all build-up. A chess match played in curved geometry, and while you can't hear anything, you can feel it, like a subsonic vibration in your metaphorical bones. One of the black holes, the larger one, pulses faintly in infrared. That's radiation from all the material it's devouring. The surrounding stars, now pulled into elongated orbits, dip in and out of visibility as gravitational lensing twists their light around the core. You're not just watching a merger, you're watching reality fold inward on itself. You wonder what would happen to a planet in this region, if by some miracle one had survived this long, maybe orbiting a distant star that managed to keep its cool. The answer? Not great. The sky would no longer make sense. Day and night would lose their rhythm. The sun might disappear behind warped space for months at a time. Tides, seasons, and radiation levels would swing unpredictably. Civilization, if it ever existed, would be over in a whisper. Still, in all this, there's awe. You're watching creation and destruction bound together. These black holes aren't just endings. Their merger will birth a new, even more massive singularity. A fresh gravitational anchor around which the shredded remains of this galaxy will someday settle. The future of this galaxy, if it has one, will revolve around that. You're almost close enough to see the warping of time itself now. The galaxy's fate is sealed. The arms are gone. The clusters have fled or fallen. And the monsters at the centre, they're still dancing. You're adrift in the core now, no more polite outskirts or delicate star streams. This is the galactic equivalent of Ground Zero, and it's lit not by calm starlight, but by the violent tantrum of matter being eaten alive. The black hole merger isn't complete yet, but it's close enough, and the gravitational turbulence is stirring up more than just stars. Here, in this compact churning zone, something has reawakened. The central engine. You probably weren't expecting this. Most people picture black holes as quiet, black voids. Mysterious, yes, but passive. Truth is, the most dangerous black holes aren't quiet. They're active galactic nuclei, or AGNs if you're short on time, and they are some of the most luminous objects in the universe. What you're watching now is a quasar ignition. It starts like a whisper. Gas and dust, funneled inward by gravitational torques and orbital decay, begin to spiral toward the black hole, forming a glowing accretion disk hotter than the surface of any star. Temperatures in this disk climb to tens of millions of degrees Kelvin. At these speeds and temperatures, atoms can't hold onto electrons. The entire area becomes a plasma blender lit by X-rays, ultraviolet light, and radiation that would sterilize a galaxy. Then, without much warning, it jets. Twin columns of plasma burst out perpendicular to the accretion disk, one shooting up, the other plunging down. These relativistic jets are launched at nearly the speed of light, punching through the interstellar medium like rebar through drywall. Each is powered by magnetic fields twisted and funneled by the black hole's rotation, a process we still only partially understand. You watch one of the jets now as it slices through what used to be a fertile star-forming region. The gas here isn't just scattered, it's ionized, stripped down and flung out at speeds that guarantee it'll never settle back into anything star-shaped again. This, ironically, is one of the ways black holes kill galaxies, not by swallowing them whole, though they're certainly trying, but by turning into these energetic, galaxy-scaled fire hoses that sterilize everything they touch. The jets are only part of it. Even the light from the quasar itself, blasting out across the galaxy, can heat and push gas away. It's called AGN feedback, and it's as brutal as it sounds. Without gas, stars can't form, and without stars, a galaxy becomes a fossil. Astronomers have observed galaxies at various stages of this process. Some, like the famous quasar 3C273, are blazing so brightly they can outshine entire galaxies, despite being powered by a single central black hole. Others, like Messier 87, display massive jets visible even in amateur telescopes. Fun fact, M87 is the one we got the first ever photo of a black hole from. Thank you, Event Horizon Telescope. But here, you're inside the furnace. The quasar phase has begun. The galactic core is glowing like a lighthouse whose bulb has just been replaced with a fusion reactor. Every bit of infalling gas becomes fuel, and you're watching what is essentially a galactic engine overheat. Jets blaze, light floods space, and in all this brightness shadows form, massive, sweeping voids where the gas has been pushed aside. These cavities, often referred to as AGN bubbles, can span thousands of light years. Think of them as aftershocks of cosmic violence, regions where matter has been bulldozed by sheer energy. You pass into one now. It's quiet here, oddly calm. But it's an artificial calm, the kind you get after a wildfire has passed, when all that's left is scorched earth and no promise of regrowth. You can still spot stars on the edge of the bubble. Some are drifting, no longer held in steady orbits. Others are racing away. But the clouds of gas? Gone. Blasted outward, superheated and accelerated into the galaxy's halo, or completely ejected into intergalactic space. This is what scientists call quenching, a process that transitions galaxies from star forming to dead. You see it all over the cosmos. Young blue galaxies, full of life, turn into quiet, red spheroids after their central black holes wake up and go full flamethrower. And while the timing and triggers are still debated, some say mergers, others say internal processes, it's clear that black holes are expert extinguishers. Historians still argue whether the quasar phase is a final evolutionary stage or just a temporary outburst. Some evidence suggests that galaxies can reignite, forming stars again after millions of years once the black hole calms down. Others think the damage is permanent, that once quenched, a galaxy never truly recovers. Here, you're watching the aggressive version. There's no room left for gas to settle. The inner galaxy is a kiln. The black hole's jets continue to burn across light years, visible even from the galaxy's edge. Light echoes from previous outbursts still ripple across the gas-poor halo. Strange glowing arcs, like cosmic graffiti. You move now along one of these light echoes. It's not a solid thing, but rather an illuminated shell, a delayed glow in a cloud of dust that caught a previous outburst. In Earth terms, it would be like seeing a lightning bolt's reflection on distant clouds seconds after the strike. Except this bolt is 100,000 light-years wide. A weirdly charming detail. Some of these echo arcs have been spotted in real life, most famously in the galaxy NGC 5548, where an earlier AGN phase seems to have left behind a ghostly light echo, illuminating gas that's no longer being directly hit. It's like watching a haunted house flicker even after the lights have gone out. You pass another jet, this one flickering at the edges. It's variable, changing shape over time. Some jets can stay stable for millions of years. Others, especially in turbulent environments like a galactic merger, wobble, stutter, or fade completely. The one you're watching, it's losing power already, perhaps starved of fuel, but it's already done the damage. At this point, the galaxy has stopped making new stars, not because the stars don't want to form, but because they can't. The raw ingredients are gone or too hot, and without new stars, the galaxy enters its twilight phase. You float now over the inner disk, or what used to be one. There's no more symmetry. The disk has thickened, puffed up by heating and turbulence. Some astronomers call these post-quasar galaxies red and dead, filled with aging reddish stars, no longer bright with star-forming blue light. You're watching the moment that transformation begins. It's eerie, really. A place once bursting with life, massive stars lighting up nebulae, newborn clusters cradled in glowing gas, now feels hollowed out, like an abandoned city where the lights are still on, but no one is home. And overhead, always the quasar burns, hungry, relentless, unapologetic. You're gliding through what was once the galaxy's most precious territory, the gas-rich heartland, where stars were born, nurtured, and burned brightly in their brief, brilliant lives. But the silence here isn't just the usual cosmic hush, it's an emptiness, a nothingness. The gas is gone. You may think of gas in space as thin, wispy stuff, and you'd be right. But it's also the lifeblood of a galaxy. Without it, stars can't form. Without stars, a galaxy can't shine, can't evolve, can't live. What you're seeing now is the aftermath of AGN feedback, the quasar's way of cleaning house with a flamethrower. Gas that once floated lazily through the galaxy's spiral arms or pooled in nebulae is either superheated and ionized, flung out in violent winds, or consumed entirely by the black hole's appetite. What's left is a galaxy gutted of its most vital ingredient. You fly past what used to be a star-forming region, a thick molecular cloud, dense with hydrogen and dust. It would have been a stellar nursery, glittering with protostars and glowing in infrared. Now, it's a skeleton, scattered particles. Some still glow faintly from the heat of recent trauma, but there's no density left to create anything new. You're looking at a miscarriage of stars, a future that never formed. Astrophysicists have a term for this slow, relentless elimination of star-forming potential: gas depletion. In some cases, galaxies lose their gas through internal processes, like winds from massive stars or supernova explosions. But in moments like this, quasar-driven, black hole-fed extinction, the entire supply is burned out or blasted away in one catastrophic phase. And here's where things get even more depressing, or fascinating depending on your mood. Not all of that gas was originally from this galaxy. Over the course of its lifetime, the galaxy collected gas through interactions with smaller galaxies, from the cosmic web of intergalactic filaments, and from its own stars recycling material back into the interstellar medium. All that slow, patient accumulation, millions of years of gathering and renewal, undone in a few million years of black hole fury. Some of the gas isn't even blasted away gently, it's stripped. A process called ram pressure stripping happens when galaxies move through dense intergalactic medium, like a swimmer hitting a strong current. The external pressure can push gas out of the galaxy, especially in this chaotic environment where gravitational tides are already pulling the structure apart. It's like the galaxy is being peeled, one molecular layer at a time. You pass through one such stripped region now, a plume of cold gas trailing behind the galaxy like a tear. It stretches for tens of thousands of light years, thin and frayed like cosmic smoke. Real-life examples of this exist too. Galaxies in clusters like Coma or Perseus show long gas tails, some visible even in X-rays, where hot intergalactic plasma has ripped away their star-forming material. Astronomers call them jellyfish galaxies for the way their tails stream behind them. Beautiful, but dying. Your spiral galaxy, now deformed and lopsided, has become its own jellyfish. And not the kind you find in tide pools. This one is in deep, irreversible collapse. Gas that isn't stripped is either falling inward, fueling the black hole, or being ejected by violent outflows. These are winds launched from the accretion disk itself, driven by intense radiation pressure. You pass one now, a vast shell of expanding plasma, moving at hundreds of kilometers per second. If there were anyone here to breathe, they wouldn't be for long. What makes this even worse is that much of this gas isn't just gone, it's hot. So hot that it can't cool down to form stars again for billions of years. It's stuck in limbo, floating through the galaxy's outer halo in a kind of eternal exile. Too scattered to clump, too energetic to rest. Scientists still argue over how permanent this state is. Some believe galaxies like this can cool their halos over time, slowly regathering gas and resuming star formation. Others suggest that the heating is so efficient, the galaxy effectively retires, aging into a red elliptical husk with no hope of rebirth. You're beginning to see that transformation unfold. The colours here are shifting. The bright blues of young, hot stars are vanishing. What's left are the long-lived red and yellow stars, the retirees of the stellar population, and while they glow with quiet dignity, they aren't renewing anything. It's all maintenance, no new construction, just slow aging, like a city with no new children. You pause near what's left of a dust lane. It used to thread through one of the spiral arms, a cold, dark river of organic molecules and silicates, raw ingredients for future planets. Now it's faded, scattered. Parts of it are ionized, fluorescing weakly in the ultraviolet. Others are simply gone, swept away by a jet or vaporized by high-energy radiation. And here's the final kick. This process isn't limited to one galaxy. The feedback effect can leak into neighboring systems. The outflows, jets, and radiation cones can spill across light years, polluting or stripping gas from nearby galaxies if they're close enough. It's like lighting a bonfire and accidentally burning your neighbour's garden. And it raises a fascinating possibility that galaxies might not only evolve due to their own central black holes, but also from the activity of others. Intergalactic peer pressure, but make it destructive. You're seeing evidence of this right now. A smaller dwarf galaxy, previously orbiting the main spiral, is being lashed by the outer edge of a relativistic jet. Its already thin gas content is boiling away. It didn't do anything wrong, just happened to be in the wrong place at the wrong time. And so, you drift onward through a galaxy that's being hollowed out. There are still stars, there's still light, but the engine of growth has stalled. The factories are shut down. The raw materials are gone, spent, or exiled. You're in the middle of a galactic famine and there's no rescue coming. The black hole continues to blaze. The jets, now tapering slightly, still punch holes in the interstellar medium. The remaining gas is scattered, not cohesive enough to recover. And in the quiet spaces between these outflows, the once busy spiral now echoes with silence. You drift through the silent galaxy like a ghost walking through the remnants of a once bustling city. No longer crowded, no longer expanding, but somehow alive again, briefly. Against all odds, amid the stripping, sterilization and gravitational mayhem, something strange is happening. You see it first in a faint pink glow, a ripple of light tucked away in a collapsing spiral fragment. Then another, bright blue specks sprinkled like sugar over a dust lane that should have been long gone. Your mind registers the truth even before you want to believe it. The galaxy is throwing one last starburst. A starburst is exactly what it sounds like, a sudden, intense period of star formation. But this isn't the happy kind you find in young galaxies just forming out of primordial gas. This one is frantic, chaotic, and very likely short-lived. It's the astrophysical version of a deathbed outburst, energy burning at both ends of the candle in one last defiant blaze. You drift closer to the region, and the colours shift. Blue-white stars, massive and newly born, shine fiercely from within tight-knit clusters. Around them, filaments of ionized hydrogen, glowing red-pink in the characteristic hue of HI regions. This is a nursery on overdrive. Massive stars here will live fast, die young, and explode. Possibly before the region even finishes forming new stars. It's breathtaking, it's irrational, and it's completely normal in a galactic breakdown. Here's the paradox. The same gravitational chaos that's destroying the galaxy is also compressing certain gas pockets. As tidal forces twist and collapse the spiral arms, as matter is funneled inward, pressure spikes. Gas clouds that were previously floating too loosely to collapse are now crushed into critical densities. Boom! starburst. Astronomers have seen this happen. In colliding galaxies like the antennae and NGC 4038/4039, starbursts erupt in knots of blue-white fire, temporary and violent. In some cases, entire clusters form in a matter of a few million years, lighting up regions with the intense radiation of OB stars and their shorter-lived cousins. You're passing through one such region now. The radiation is brutal. High-energy photons race outward, ionizing gas in every direction. You can see shock fronts where the newborn star's light is pushing against denser clouds. Some of these stars are so large, 50, 60, even 100 times the mass of the Sun, that their lives will be measured in mere millions of years. Not long enough to drift very far. They will explode right here within sight of their birthplace. And that, ironically, will end the starburst. These supernovae, powerful as they are, heat and disrupt the surrounding gas. Their shock waves may trigger a little more star formation at first, but over time, they blast apart what's left of the fragile clouds. The next generation of stars never gets the chance. It's a process known as self-regulation, or if you're feeling poetic, death by brilliance. Historians, by which we mean those friendly neighbourhood astrophysicists with supercomputers and coffee addictions, still debate whether these final starbursts contribute meaningfully to a galaxy's mass, or whether they're just a last cosmic hiccup. Some models suggest these bursts can form massive, bound superstar clusters that survive long after the galaxy fades. Others argue that much of the mass is lost to feedback, blown out before it can do much of anything. You pause in the middle of one of these newborn clusters. The stars around you are blinding. Their ultraviolet radiation ionizes the gas into surreal shapes, columns and pillars glowing like stained glass. You drift past a baby blue giant, not yet 1,000,000 years old, spinning so fast it bulges at the equator. Its gravity is unstable, its lifespan already ticking toward collapse. Nearby you see an older star, relatively speaking, puffing up as it nears the end. It's lived just long enough to witness its neighbours forming. Soon it will die, spewing heavy elements into space in one final enrichment of the interstellar medium. It's a little cosmic recycling before the lights go out. And then you notice something. A small, irregular knot of stars, no more than a few dozen, floating independently, just outside the brightest part of the burst. It's detaching. This cluster, pulled free by gravity, may go on to orbit the future remnant of the galaxy as a satellite, or become a rogue globular cluster, drifting through intergalactic space. They're not just hypothetical. We've observed such clusters trailing behind interacting galaxies, remnants of these last gasps. Some may even end up orbiting entirely new galaxies if they get caught by a passing gravitational field. It's a cosmic game of hot potato, but the stakes are stellar evolution. The deeper into the core you drift, the more these starburst pockets stand out against the fading background. It's like fireflies in the smoke, moments of brightness amid the ash, but it doesn't last. You're seeing the end of the burst already, even as you admire it. The gas is thinning, the feedback from the black hole is still active, and now the radiation from the new stars is adding to it. That's double the feedback, double the chaos. The molecular clouds are getting shredded. One by one, the stellar nurseries flicker out. Still, there's a kind of tragic dignity to it. This galaxy, ruined and reeling, found one last way to shine. It made new stars, beautiful ones. They will live and die with the memory of what the galaxy once was, before the arms unraveled, before the jets fired, before the monster in the middle started feeding again. There's something you should know. We might be next. Our Milky Way is currently on a collision course with the Andromeda Galaxy. In a few billion years, we'll go through this exact kind of process. Gas will be stirred, arms will collapse, black holes will dance, and yes, there will likely be a starburst, maybe even two. So what you're watching isn't rare. It's the life cycle of galaxies. The starburst is just one phase, a flare before the fall. You float above the last of them now. The glow is fainter. The gas is nearly gone. The blue-white light of newborn stars is fading into the reddish hue of those destined to live long, lonely lives. And overhead, always, the black hole waits. The accretion disk flickers. The jets sputter. The fire is burning out, but for a brief moment this galaxy remembered how to shine. The starbursts are already fading behind you, like echoes in a cathedral where the choir has stopped singing. You drift deeper now into the galaxy's core, what remains of it, where the chaos is no longer just in the light and gas but in the movement itself. Things are falling. Everything is falling. At first the collapse feels abstract. You see stars on strange paths, curving and looping in irregular orbits, like marbles set loose on a warped trampoline. But soon the patterns become clear. They're not just wobbling, they're sinking. This is the quiet cruelty of dynamical friction, a process that sounds gentle but is anything but. It's not friction like rubbing your hands together or brakes squealing. This is gravitational friction, a consequence of motion through a field of other masses. Imagine walking through a crowd. Even if no one touches you, their presence slows you down, shifts your momentum, subtly changes your path. That's what's happening here on a galactic scale. Massive objects, like globular clusters, massive gas clouds, well, what's left of them, or even stars in the central regions, are ploughing through the thick soup of the galaxy's interior. As they do, they leave behind gravitational wakes, little pockets of denser mass that tug at them from behind. That constant gravitational pull drains their energy, slowly, inexorably. And so they fall inward. One by one, orbit by orbit, you watch them spiral closer to the black hole at the galaxy's core. Some are still on wild elliptical orbits, sweeping out in grand arcs before diving back toward the center. Others have already lost that freedom. They've settled into tighter paths, less graceful, more frantic. You pass by a massive star cluster being dragged inward, its shape warping slightly with every pass through the denser core. You can feel the tension. It's fighting to stay intact, but the tidal forces are winning. The outer stars are peeling off like paint in heat. Soon, this cluster will be nothing more than a stream, another streak of light marking the road to nowhere. Dynamical friction doesn't just change orbits, it changes structure. The central region of the galaxy, the core that once hosted a mild-mannered bulge of older stars, is now becoming a dense, disturbed swarm. This isn't just random chaos. It's a gravitational funnel. Everything heavy is sinking inward. This also applies to the two black holes. Remember them? The original central black hole and the invader from the galaxy's supermassive suitor. They're still spiraling toward each other, but now they're dragging whole clouds of stars along for the ride. The more massive you are, the faster you sink. That's the cruel logic of this phase. Big star clusters fall faster than smaller ones. Dense clouds are funneled inward, while lighter gas is left scattered in the outskirts. It's a natural sorting process, like cosmic sedimentation. The galaxy is settling into its final form, and it's a messy, lumpy, distorted core wrapped in fading stellar remnants. You might be wondering, if everything's falling, does anything get out? Well, yes and no. Some stars, those with just the right energy at just the right angle, do escape. The gravitational nudges they get from falling clusters or passing black holes can give them enough of a kick to break free. These become hypervelocity stars, racing off into the dark at thousands of kilometers per second. Most, though, just fall in. And speaking of falling, welcome to the weirdness zone. As objects near the black hole, space-time begins to bend dramatically. You're not quite at the event horizon yet, but you're close enough that physics starts to behave like it's had one too many drinks. Orbits precess. time slows. Light bends in awkward arcs. Stars disappear and reappear as gravitational lensing warps their paths. Historians and astrophysicists still argue over what this region really looks like. Even with powerful simulations, our understanding of the very inner dynamics of collapsing galactic cores is full of educated guesses. It's hard to simulate millions of stars, relativistic gravity, and supermassive black holes all at once without, melting your server farm. You, however, are seeing it firsthand. The space around you is crowded, strangely so. Despite the galaxy's collapse, there's more mass here than ever. The core has become a gravitational sponge, pulling in everything dense and unwilling to resist. Some stars are moving at ridiculous speeds, on orbits that loop in tight spirals around the black hole, completing a revolution in mere days or even hours. You pass by one such star, bright, blue-white, spinning rapidly and streaking along an elliptical track like it's auditioning for a sci-fi roller coaster. Stars like this exist in real life too. Near the supermassive black hole at the centre of our own Milky Way, we've observed stars like S2, which whips around Sagittarius A star once every 16 years, getting within a few billion kilometres of the black hole itself. Here, though, things are more extreme. The black hole is bigger, the orbits are tighter, the stars are fewer, but wilder. Another strange sight: stellar collisions. They're rare normally. Stars are tiny compared to the vast distances between them, so even in a crowded core they usually just pass by each other. But here, in this compressed gravitational stew, those odds improve. You spot two stars skimming dangerously close. Their outer atmospheres brush, creating a burst of heat and X-rays before gravity pulls them apart again. Some don't miss. When they collide, the result is messy, merging into massive, unstable stars that shine briefly before collapsing or exploding. These blue stragglers, as they're sometimes called, are younger looking than their neighbours, a side effect of being reborn through stellar violence. Another quirky cosmic tidbit: this environment may also birth intermediate mass black holes, not as monstrous as the supermassive ones, but bigger than your average stellar corpse. They're forged in runaway mergers, born from stars that collide again and again, growing in mass like gravitational matryoshka dolls. You pass by one now, it's barely visible, more a shadow than a presence. But its gravity leaves a mark. Nearby stars swirl around it, orbiting something they can't see. It's not big enough to escape, though. Soon, it'll likely fall into the main black hole, another stepping stone on the road to galactic collapse, and still, everything falls. You can feel the motion now, not through sound or vibration, but in the warping of space around you. The inner galaxy is draining into its centre like water in a funnel. Stars, gas, clusters, even gravity itself, concentrated, condensed, pulled inward toward the inescapable. The galaxy is no longer a city or a spiral or a disk. It's becoming a core, a spheroid of heat and motion and gravitational madness. And in the middle, the black hole waits, unblinking, immobile, not hungry, consuming. You're deeper now than you were ever meant to go, right into the galaxy's inner sanctum. Here, the stars don't so much orbit as cling. They spiral in desperate loops, some in shapes so warped they look like galaxies themselves. The light is strange here, bent, duplicated, sometimes delayed. You're inside what physicists sometimes call the sphere of influence, the region where the black hole's gravity overpowers all other sources. It's like being inside the sun's corona, if the sun were invisible and trying to consume reality. And this is where things get a little spaghettified. Ah yes, spaghettification, the most deliciously named astrophysical horror show in the universe. You've heard it before. Get too close to a black hole and gravity stretches you like a noodle. The idea is simple, if not comforting. The gravity on your feet, or whatever passes for them at this point, is dramatically stronger than the gravity on your head, and this difference pulls you apart. But let's clarify something. Not everything gets spaghettified. In fact, most stars do not. Especially near supermassive black holes, which are so large that the gravitational gradient, the difference between the pull on one side and the other, isn't extreme until you're very close. A sun-like star can actually pass within a few dozen light hours of a supermassive black hole and still survive if it's on the right path. Still, some aren't so lucky. You're about to witness a tidal disruption event, or TDE. It starts innocently, just a star on a weird orbit, probably thrown inward by all the dynamical friction we talked about earlier. It's on an elongated path, one that brings it dangerously close to the black hole's tidal radius, that invisible line past which stars go in but don't come out. And then it happens. The star stretches, not all at once. It warps slightly, like a balloon squeezed at one end. The leading edge of the star falls faster than the trailing edge, and that difference turns it from a sphere into a glowing streamer. You see tendrils of plasma peel away as the star elongates, shedding mass into the black hole's grip. It's not just destruction, it's transformation. Roughly half the star's mass slingshots outward, thrown into weird, high-energy orbits. The rest spirals inward, joining the accretion disk in a blaze of radiation. The whole thing glows in X-rays, ultraviolet and soft visible light. A cosmic flare that can outshine an entire galaxy for a brief moment. We've seen this, by the way. Observatories have caught real-life tidal disruption events lighting up distant galaxies, as if someone briefly turned the brightness slide to max. One such case, ASASSN-14LI, a catchy name I know, was observed in exquisite detail as a star was torn apart by a black hole just 290 million light-years away. A cosmic tragedy, yes, but also a data-rich goldmine for astronomers. And here you are, watching it unfold. You float beside the dying star, now stretched into a glowing crescent. The gas on the trailing edge is heating up, colliding with itself, forming shockwaves. You can almost imagine hearing it scream, if only space allowed for sound. But it doesn't. Just light, heat, motion. Eventually the star is gone. Not with a bang, not really. More like a long, drawn-out sigh. A final shimmer as its last fragments join the whirlpool around the black hole. Its light will echo across the galaxy's remains for millennia, a gravestone made of photons. You turn to look around and realize it's not the only one. There are others, dozens, maybe hundreds, on similar paths. Not all will be torn apart, but the ones that are, they mark the inner limit of the galaxy's existence. Because here's the truth, this is where the galaxy ends. Not in space exactly. It's still full of stars after all, but in function. Nothing out here orbits like it used to. The spiral structure is gone. The core is a mess. And what's left, inside this influence zone, is more black hole than galaxy. It's worth noting that this zone expands over time. As the black hole feeds and grows, its gravitational reach increases. The more it eats, the more it can eat. It's not exponential, thankfully, but it's relentless. The central black hole that started all this may have been a few 100 million solar masses. Now it's probably closer to a few billion. Astronomers estimate that black holes in the centres of galaxies often grow by merging with others and by consuming stars and gas through exactly these kinds of events. This process may be one reason most large galaxies have supermassive black holes, even if their current accretion activity is low. There's also a dark, slightly unnerving idea floating around in the literature that some of the most massive black holes out there, real monsters tipping the scales at 10 billion solar masses or more, might have formed entirely through this kind of long-term cannibalism, merging galaxies, repeated tidal disruption events, endless infall. Their host galaxies gone, devoured. What's left? Just the singularity. You float deeper still, where even light begins to feel like it's hesitating. The gravitational lensing is stronger here. You can see stars duplicated across the sky. Once, twice, sometimes 3 times, twinkling through space-time's warping like mirrors in a funhouse. Except there's no fun, just bending. And here's another little surprise. Some of these stars aren't just being disrupted, they're orbiting within the black hole's inner influence zone. Fast, tight, close, but still alive, for now. These are the survivors. The stars that somehow found the knife's edge of gravitational stability and walk it like acrobats. Their orbits might last thousands of years, or end in a single misplaced nudge. But for now, they exist in a kind of twilight equilibrium, dancing with death and pretending not to notice the music has changed. One final note, since you're probably wondering, no, you're not in danger of crossing the event horizon. Not yet. That moment comes later, much later. And when it does, it won't be stars doing the falling, it will be everything. You hover now above the very edge of hunger itself. The galaxy's collapse has narrowed to a single purpose, feeding the black hole. Not metaphorically, not symbolically, physically. Gas, dust, shredded stars, the broken bones of the spiral arms, it all ends up here, forming one of the most terrifyingly beautiful structures in the universe, the accretion disk. It doesn't look like a disk in the way a plate does. It's warped, thick in the middle, uneven, blazing. The closer you get, the harder it becomes to comprehend with normal senses. Distances lie, speeds bend. Time stops meaning anything useful. But here's what you can observe. The material spiraling in is hotter than most stars. As gas and plasma rotate in the disk, they rub together, compress, collide, shear. The friction doesn't slow them down, not yet. It heats them up to millions of degrees. It's friction in the same way a meteor heats up in Earth's atmosphere. Relentless, violent, and brilliantly bright. You're watching this disk blaze in X-rays, ultraviolet and extreme heat, glowing across the electromagnetic spectrum like a cosmic lighthouse with zero chill. The closer a particle gets to the center, the faster it spins, approaching significant fractions of the speed of light. You're witnessing what may be the fastest natural motion in the universe, short of light itself. And just above the disk, you see something stranger still. A glowing puffy halo of radiation and particles. The corona. It's not unlike the solar corona around our own sun, but on a scale and intensity that makes the sun look like a toddler with a flashlight. It's formed by magnetic turbulence in the accretion disk. Violent reconnection events that twist and snap magnetic field lines, accelerating particles to near relativistic speeds. The corona rains high-energy photons, especially X-rays, onto the disk and surrounding space. These rays penetrate everything. If you were a gas cloud even remotely near this mess, you'd be ionized and vaporized in seconds. If you were a planet, well, you wouldn't be anymore. The corona, the disk, the jets, they're all part of the same monstrous engine, each feeding on the next, each maintaining the cycle of falling, heating, flaring, and vanishing. A quirky astrophysical detail. These disks are often not perfectly flat. In fact, many accretion disks wobble, a phenomenon called precession. Like a tilted spinning top, the whole structure can slowly change orientation over time, driven by frame-dragging effects from the spinning black hole or irregular inflows of matter. Right now, you're seeing exactly that. The disk is wobbling. You can feel the orientation shift subtly as stars and matter enter from different directions. It's mesmerizing until you realize what it means. The galaxy has lost all symmetry. There is no axis, no order, just a growing core of madness. Material near the center of the disk has seconds, maybe minutes, left to exist. From your perch you observe one final stream of gas, torn from a half-shredded star, spiral inward. It joins the disk at its outer edge, heating rapidly, brightening as it spirals faster and faster toward the innermost stable circular orbit, a sweet spot of death, the last safe lane before material plunges past the event horizon. That last orbit, that edge of oblivion line, depends on the black hole's spin. If the black hole isn't spinning, the innermost stable orbit is about 3 times the radius of the event horizon. But if it's spinning rapidly, and this one is, it gets closer, much closer. This means material in the disk can orbit terrifyingly close before being pulled in. More energy, more heat, more spectacle, and then gone, no sound, no flash, no scream, just nothing. Material crosses the event horizon and vanishes. Its energy leaves behind a trace in the disk, but the matter itself, lost, consumed. Its information, according to one school of thought, destroyed. According to another, encoded in the black hole's surface. According to a third, well, let's just say physicists still don't agree. Yes, historians of the cosmos still argue whether black holes preserve or erase information. It's called the black hole information paradox, and it's one of the deepest unsolved problems in theoretical physics. Hawking, string theorists, loop quantum gravity advocates, they all have opinions, no one has proof. You're just watching the food go in. Another strange detail. The disk doesn't go all the way down to the event horizon. There's a plunge region, a no man's land between the inner edge of the disk and the horizon itself, where matter stops spiraling and simply falls. You can't see it clearly. No one can. It's not lit. There's no time for anything to radiate. It's a free fall into silence. Back out at the disk's edge, though, you can still see signs of past meals. Massive clumps of iron, carbon, and heavier elements, ashes of old stars, circulate like debris in a whirlpool. Some are dense enough to emit their own radiation. Some collide and fragment. Some linger, spiraling slowly inward over centuries. And above it all, the jets are still firing. You follow one upward. It stretches light years into the intergalactic dark, channeling matter through magnetic field lines twisted by the black hole's spin. This jet doesn't come from inside the black hole. It's launched from just outside, from the chaotic region of space where plasma and magnetic fields tear through each other in near light-speed friction. These jets carry away angular momentum, helping the black hole accrete more matter efficiently. They also inject energy into the surrounding medium, blasting holes in gas clouds, lighting up the remnants of the galaxy, and even triggering star formation elsewhere if the conditions are weird enough. Yes, that's right. The black hole that just obliterated this galaxy might accidentally spark life in another. Space has a sense of humour. You drift back down toward the disk, careful not to enter the inner region. Not that it would matter, this isn't a place you could survive anyway. Even the idea of being here is absurd. But you linger for a moment longer, just outside the worst of it, watching as another filament of matter spirals in, lights up, and fades away forever. This is the black hole's buffet table, an endless spiraling feast of mass and memory. Once it was a galaxy. Now it's a meal. You stay close to the accretion disk, watching the last embers of the galaxy fall inward, knowing full well you're witnessing the final chapter of its structure. But just as you expect the black hole to settle, to digest in silence, something stirs in the core, something monumental. The two black holes, the original central one and the massive interloper that pulled the galaxy into all this, have been circling each other for millions of years, locked in a decaying dance. But now, at last, they are merging. It's not like a collision of any objects you've ever seen. There's no flash of light, no explosion, just a tightening of orbits so tight that even space-time itself begins to squeal. The black holes spiral inward, radiating away energy in the form of gravitational waves, subtle ripples through the very fabric of the cosmos. These waves pass through everything, stars, gas, you, with no resistance. You don't feel them, but the universe does. If you had the right instruments, say a laser interferometer the size of Earth's orbit, you'd hear the final seconds of this merger as a faint rising chirp. And then a sudden silence, a moment where even the warped light seems to pause, and then they become one. A new core is forged. This isn't just a slightly bigger black hole. This is a different object entirely, a product of two giants coalescing, not only in mass but in spin, in geometry, in horizon structure. The event horizon now quivers briefly, like the surface of a lake just struck by a meteor. These brief distortions are called ring downs, and they quickly settle, releasing the final notes of gravitational energy into the universe. You're floating just outside the carnage, but you can feel the change. The warped orbits, the hot gas, the leftover stars, all begin to shift. The gravitational center has changed. It's stronger, tighter, more efficient. This black hole is no longer part of the galaxy. It is the galaxy. In the moments following the merger, the surrounding stars and gas behave like birds after an earthquake. They jostle, they flare, some scatter, others fall in. The accretion disk, already bloated with wreckage, realigns slightly to the new center of gravity. Weirdly, there's a kick. That's right. The newly merged black hole moves. Not a lot, but enough to matter. Because gravitational waves aren't always emitted symmetrically, the black hole recoils slightly, like a shotgun firing without a brace. This phenomenon is called a gravitational recoil, and in extreme cases it can be strong enough to eject the black hole from the galaxy entirely. You pause at that. Can you imagine? A supermassive black hole, billions of solar masses flying through space like a rogue bullet, dragging a small entourage of trapped stars and debris, a whole galaxy's heart, torn out and flung away. But in this case, not quite. The kick is there. You see the faint lurch, feel the subtle wobble, but it's not enough to eject the core. The black hole resettles in the center, and for the first time in millions of years, the gravitational field starts to stabilize. The destruction has passed. What remains now is a core remnant, no longer a spiral galaxy, no longer a system of order and arms and starbirth. It's a spheroidal haze of aging stars, gas-stripped and structurally transformed, a shadow of what it was. And still, something survives. You float through the new core, and even amid the chaos you notice small patterns trying to re-emerge. A few star clusters have realigned their orbits. Dust trails begin to wrap around the core in slow ellipses. There's no disk, no arms, but there's motion. Not the clean, elegant rotation of a spiral galaxy, but the lumpy, uneven drifting of an elliptical galaxy in the making. Because that's what happens next. After the destruction, after the feeding, after the merger, the galaxy tries to rebuild, but it can never return to what it was. Spiral galaxies don't survive this kind of event. Their order is gone. Their cold gas, needed to form arms and support structure, is gone. What forms instead is something rounder, puffier, less elegant. An elliptical galaxy. We see these across the universe. Ancient, red, quiet. No young stars, no bright arms. Just old suns in long, lazy orbits around a bloated core. For a long time, astronomers thought ellipticals were simply born that way. Now we know better. They are the end stage of spirals, and this one, it's just beginning that transformation. Historians still debate whether ellipticals formed primarily through these major mergers, or if smaller processes can build them over time. Some suggest that repeated minor mergers, lots of little galaxy snacks, can slowly puff up a spiral into an elliptical without all this drama. Others argue that only major collisions like the one you just watched are violent enough to fully destroy a spiral's form. You float now through what used to be the central bulge, now a glowing, stabilized region of slow-moving stars. It's quieter here. The jets have tapered off. The disk is cooling. The black hole is no longer devouring at a frenzied pace. It's entered a quiescent phase. Still dangerous, still massive, but not as active. This is what many black holes become, eventually. After the feeding ends, they settle into long periods of quiet. Unless disturbed again, say by a fresh galaxy wandering into range, they simply wait. You pass by one final cluster of stars, survivors from the old core. Their orbits are tighter now, but they're stable. They may circle this black hole for billions of years, long after the rest of the galaxy fades. A cosmic vigil. Above you, the shape of the galaxy continues to shift. The remnants of the spiral arms are long gone. The last gas clouds have been stripped or consumed. The entire system is rounder, redder, and older. The transformation is complete. Not the death of a galaxy, but its reinvention, from spinning spiral to swollen sphere, from bright, messy youth to quiet, massive age. It is no longer a place of growth, but of memory. And in its heart, a newborn black hole stitched from two, quieter now, but so very, very hungry. You hang in the silence that follows a cosmic thunderclap. Behind you, the two black holes are no longer two. The core has settled, at least as much as something held together by gravity and existential dread ever truly settles. The jets have faded, the accretion disk is dimming, and even the last whimpers of starburst light have blinked out. But even now, something else is moving. Not through space exactly, but as space. You're about to witness the strangest ripple you'll never see. Gravitational waves. If that phrase feels familiar, it's because it's one of the more poetic bits of physics. Literal distortions of the fabric of space-time, sent out when the most massive objects in the universe accelerate violently. Especially during things like, a galactic black hole merger. The waves don't shimmer, they don't sparkle. But if you could see them, if your vision were sensitive not to light but to the stretch and squash of space itself, you'd see a silent shockwave expanding outward in all directions, warping everything it touches by the smallest of margins. And when I say smallest, I mean absurdly small. When we first detected gravitational waves on Earth in 2015, high LIGO, the distortion caused by two black holes merging 1 billion light-years away changed the distance between mirrors by a fraction of a proton's width. A proton. That's the kind of tiny we're dealing with. But here, floating far closer to the source, the effect is bigger. Not life-threatening. Though let's be real, we're well past worrying about your imaginary skeleton's safety, but perceptible. Stars drift just a bit. Orbits wobble faintly. The entire fabric of the local cosmos breathes just for a moment, and then it passes, a ring, a ripple, a memory. The waves travel outward forever, weakening as they go, eventually becoming part of the background hum of the universe. Even now, Earth is being bathed in ancient gravitational murmurs from long-dead events. With the right tools, scientists can listen to these murmurs like archaeologists with stethoscopes pressed to the bones of space-time. Historians, yes, those again, still argue over just how common these massive black hole mergers are. We know that most galaxies host supermassive black holes. We know that galaxies merge often. So logically, these events should be happening everywhere, all the time, in slow motion across the universe. But catching one as it happens? That's the tricky part. Most of the time, we only get hints, X-ray flares, changes in orbital motion, and eventually the gravitational waves themselves. But direct real-time observations of two galactic cores merging, that's a cosmic jackpot, and that jackpot just hit. The gravitational wave you just watched may travel for billions of years before intersecting another sentient civilization, assuming there's anyone out there with enough curiosity and lasers to catch it. For them, this moment you're floating through will become a dot on a timeline, a chirp in the data, a clue to a cosmic mystery they'll never fully see. That's the funny thing about black hole mergers. They don't just erase matter, they erase context. Once complete, all that remains is the afterglow, and even that fades. You drift back toward the galaxy, or what's left of it, and something odd happens. It's quiet. I mean, sure, the universe is always quiet, but this is different. The chaos is gone. The distortions have calmed. The stars aren't racing anymore. They're settling. The remaining gas is thin, hot, and stretched, but no longer agitated. The jets have turned off. The accretion disk is cooling, barely glowing now. You've entered the post-merger calm, a brief but notable phase in the galaxy's evolution. The gravitational waves may be gone, but their consequences linger. You notice that the stellar distribution around the new black hole has changed. It's puffier, more isotropic. The chaos of the merger has randomized many of the star's orbits, a process called violent relaxation, an incredibly dramatic name for what amounts to gravitational musical chairs. The center now looks like a glowing spherical swarm, not a disk, not a core, something more primitive, more disordered, and yet balanced. Even the galaxy's shape reflects this. From the outside, it appears more like an elliptical now, a massive, featureless oval of fading light. No spiral arms, no dust lanes, just a smooth gradient of stars from core to edge. And yet, in this new form, it's stable. That's the cosmic irony, isn't it? Destruction leads to equilibrium. Collapse brings calm. The galaxy has lost its identity, its structure, and its future of star formation. But what it gains is longevity. Elliptical galaxies like this, born in violence, raised in hunger, can last for trillions of years. Their stars burn slowly, and with no fresh gas to feed on, they age like statues, glowing faintly long after the rest of the universe has gone dark. You glide now along the outer edge of the gravitationally relaxed core. Some stars still bear the scars of the merger, ejected into wide, looping orbits that take thousands of years to complete. Some were flung into the halo, destined to orbit the galaxy's ghost for eternity. A few may have even escaped entirely. Yes, that's right, escapers. When the black holes merged and the gravitational waves kicked out momentum, some stars were catapulted from the galaxy with enough speed to reach intergalactic space. These hypervelocity stars are the ultimate wanderers, exiled not by choice but by math. There may be one near you right now, back home, moving too fast, too far, on a path with no return. Here, though, you stay with the center. You pass close to the event horizon of the merged black hole. Not too close, but close enough to feel the subtle curvature of light. You're not falling in, you're not spiraling, just floating in the quiet wake of the greatest merger this galaxy will ever know. This is the moment after. The moment when the galaxy breathes in and doesn't know what to do next. It won't birth new stars, it won't regrow arms, it won't spiral or shine in the way it used to, but it will exist. It will hold its shape. It will linger in the sky of some distant observer, a quiet red smudge with no hint of the carnage that created it. That's the legacy of gravitational waves, not noise but silence, the silence left behind after the ripple passes, after the collision ends, after the core resets. You look one last time at the core, now fused, and understand. The galaxy has become something new. The stars remember, but space does not. You've floated through collapse, through jets, through warping disks and merging monsters, and now, oddly, you're not in the center anymore. You've drifted outward into the galaxy's outer reaches, past the core, past the scoured inner halo, into the outer debris field of this shattered system. But don't be fooled by the term debris. Out here, in the cold halo, is a population of stars and clusters that have endured the whole event. They are the survivors of the plunge. Some of them, many in fact, shouldn't even still be here. By all accounts, the inner galaxy was unstable. Starbursts exploded. The accretion disk flared. The gravitational tides shredded structure like wet paper. And yet here they are, drifting through elongated, eccentric orbits, like bewildered refugees returning to a city that no longer exists. You watch one such survivor, a red giant trembling slightly as it crosses the boundary of the old galactic disk. Its orbit has been stretched by repeated gravitational tugs. It takes thousands of years to complete a single loop around the now stabilized core. For all it knows, the galaxy is still in chaos. It has no idea what it escaped. Others were even luckier. During the collapse, when the black hole spiraled inward and the inner disk fractured, some stars were ejected outward. Not violently, not at hypervelocity, but with enough of a nudge to shift them into new, stable orbits in the halo. They now cruise around the new core on tilted, looping trajectories, many at bizarre angles. This is no longer the flat, organized rotation of a spiral galaxy. This is chaotic motion, stars in all directions, all inclinations, some circling clockwise, others counterclockwise. There's no plan, no axis, just motion. It's messy, but it's survival. Astrophysicists call this post-merger population the stellar halo. Many galaxies have them, and in cases like this they are full of oddities. Old stars in strange places, clusters that shouldn't still be gravitationally bound, rogue stars moving through like they're just passing through the wrong neighborhood. And then there are the ones that didn't just orbit the core, they left. You follow the trail of one such object, a small metal-poor star, probably from a globular cluster once nestled deep in the spiral's arms. It was flung outward during the black hole merger recoil, just barely missing the gravitational threshold for escape. Now it's on a highly eccentric orbit, plunging in close, then soaring out for tens of thousands of light years, barely brushing the edge of galactic gravity. It may return, or it may get nudged one last time, tipped into true escape velocity. These borderline cases fill the galaxy's outer regions, each one a gravitational coin toss, forever flipping. Some do escape. Yes, despite the galaxy's enormous gravity, some stars were given enough of a boost by the merger's gravitational recoil or by chaotic three-body interactions near the black hole to exceed galactic escape velocity. These are the hypervelocity stars, and they're still out there, moving alone through intergalactic space, cold, isolated, glowing. We've detected these in real life. In the Milky Way, several stars have been clocked at speeds over 1,000 kilometers per second, fast enough to leave the galaxy entirely. Many of them likely originated near our own central black hole, Sagittarius A star, flung outward in gravitational slingshot events.
You pass close to one now. It's already light years from the galaxy's edge and getting farther with every heartbeat. Its fate? To drift between galaxies for the rest of time, unless intercepted by some other gravitational body. But the void is vast, and chances are it will end its days alone. Oddly poetic, isn't it? A star, forged in a system rich with light, doomed to die in silence between the stars. But most of the survivors don't escape. They stay. They adapt. The galaxy's remaining clusters have begun forming new orbits around the transformed core. You pass one, dense, ancient, humming with red giants. Its path loops high above the galactic plane, angled like a comet. This used to be a tightly orbiting bulge cluster. Now it swings wide every few million years before diving back toward the core, where the black hole's gravity tugs at it, stretching its edges. Not all clusters make it through this. Some will dissolve over time, pulled apart by repeated passes through the central region. Their stars will spread out into streams, wrapping around the galaxy like ribbons, faint, thread-like, persistent. You'll see more of those soon. Still, others thrive. Their orbits stabilize, their stars continue to age in quiet companionship. The galaxy may be dead as a spiral, but it's not empty. And that brings us to one of the stranger outcomes of this process: new orbits around the black hole. The merged singularity at the galaxy's core is now the undisputed ruler of the region. The mass has increased, the gravity has deepened, and the stars that remain close are now bound in tighter orbits than ever before. Some of these are wildly eccentric, oval-shaped loops that dip close to the event horizon before slinging the star far back out again. You drift alongside one, a bright star, glowing orange, aging gracefully. Its orbit carries it within just a few dozen light hours of the black hole. During those near passes, relativistic effects distort its path, warping its speed, causing its orbit to precess, a strange, slow turning of the ellipse. In fact, that's how we proved Einstein was right about general relativity. Stars like this, called S-stars, have been observed orbiting the black hole at the center of our own Milky Way. Their precise movements, tracked over decades, show space curving exactly as relativity predicts. And now, this post-spiral galaxy has a whole new crop of them, each one a silent testament to the merger, to the fall, to the fact that even after a galaxy is consumed by a black hole, not everything falls in. Some stars find a way to orbit forever, some find a way to escape, and some simply remain. You float now at the outer edge of the galaxy's influence, looking inward at the faint, red glow of its core. The jets are quiet, the dust is gone, the spiral arms have vanished. But in their place, motion, gravity, memory, and stars, scattered and lopsided, but still shining. You're coasting now along the galaxy's outer edge, far from the screaming violence of the black hole's core, and what surrounds you is strange. Not quiet, not peaceful, just strange. Because the spiral arms, those graceful, symmetrical structures that define the galaxy's identity, are still here. Sort of. They're not spiraling anymore. They're not even connected to anything. But their ghosts linger, long, winding trails of stars and dust, drifting outward like cosmic jellyfish tentacles. These are the tidal tails, the visible aftermath of gravitational chaos, etched in starlight. Tidal tails are what you get when galaxies are torn apart. When one falls into a black hole, or another galaxy, or both, and its carefully arranged structure is pulled apart, star by star. They're not trails of destruction exactly. They're more like fossils in motion, proof that something beautiful once held everything together. And in this galaxy's case, the tails stretch out for hundreds of thousands of light years. You drift along one now. It's faint, easily missed from afar, but up close it's a thread of scattered suns. Some are clumped in clusters, others are totally alone, like breadcrumbs lost along the trail. You pass one of these lonely stars, glowing softly in the blackness, and you can't help but feel a pang of sympathy. It wasn't meant to be out here. It didn't want to be exiled. It was part of something structured, something balanced. Then came the black hole, the merger, the destruction, and now this. A spiral arm that forgot how to be a spiral. These tales aren't just random, though. They trace the dynamics of the galaxy's final years. Each arc, each kink in the trail tells a story. A sudden jerk here marks the early tidal pull of the incoming black hole. A looping curve there shows where the core's recoil during the merger disturbed the orbit. These aren't just leftovers, they're history. And there are two of them, usually. Most disrupted galaxies form symmetric tidal tails, one leading, one trailing, like arms flung out in surrender. You've probably seen real examples. The Tadpole galaxy, with its impossibly long stellar streamer, or the Mice galaxies, locked in mutual destruction, leaving bright tails behind them. The tails you're in now are less photogenic, but every bit as meaningful. There's debate among astronomers about how long these tails last. Some simulations suggest they fade in a few 100 million years, blending into the intergalactic background. Others argue they can persist for billions of years, especially in low-density environments where nothing disturbs them. Here, in this galaxy's lonely corner of the universe, the tails are hanging on. But not forever. You pass through a clump, a small tidal dwarf galaxy maybe. That's another strange feature of these stellar leftovers. Sometimes when the tails get dense enough, their gravity clumps stars and gas together into new, independent systems. These aren't born from traditional galactic collapse. They're recycled, forged in chaos. This one's small, a few thousand stars maybe, orbiting one another like they're trying to pretend everything's fine. They may stabilize, become a satellite of the newly formed elliptical remnant. Or they might dissolve over time, just another feature of the tail. There's something bittersweet about it, like watching a side character from a tragedy try to carry on the story. And then, as you drift farther from the galactic center, you realize the tails aren't just made of stars. There's dust here, gas too, cold and quiet, trailing behind the main event like forgotten luggage. It's too diffuse to form stars now, too stretched to be useful. But in time, maybe, it will drift into denser pockets. Maybe, in a few billion years, it'll collapse again. Reform. Begin anew. Historians still argue whether this happens frequently. Some claim tidal tails are simply the end, signatures of death with no rebirth. Others see them as seeds, chaotic beginnings for dwarf galaxies, new structures that will evolve on their own, given enough time and solitude. It's one of the open questions in galactic archaeology. Are tidal tails tombstones or wombs? As you drift past another star stream, looping elegantly into the void, you start to understand the answer is probably both. Some tails lead to nothing, others spark something new. All of them speak of what used to be. And here's a strange twist. These features are often the only part of a destroyed galaxy that other observers can see. From far enough away, the remnant galaxy might look like a typical elliptical, red, smooth, unremarkable. But those tails, faint and glowing, tell a very different story. That's how we discovered many past mergers. Astronomers, studying galaxies with halos full of weirdly aligned stars, found faint tidal tails wrapping around them, proof that they'd devoured companions in the past. Galaxies like NGC 7252, nicknamed the Atoms for Peace galaxy, show both the remnant core and delicate tails extending outward like arms trying to remember how to hug. You hover now at the end of one such tail, and from here the core is barely visible, just a dim, red blob in the black. But the tail? It curves, still glowing, still moving. Because these structures don't freeze in place. They orbit, slowly, elegantly. Even as they decay, they maintain momentum. Some stars will fall back into the galaxy's gravity. Others will be lost forever. The tail will fade, but not before leaving a final mark on the cosmic landscape. You begin to realize this is a kind of afterlife. The galaxy may be gone, its structure may have collapsed, but the stars remember. Their paths trace a memory no black hole can erase. It's quiet here, on the tail's edge. You're far from the violence, the jets, the disk, the merger. But the beauty is undeniable. One last touch of spiral, one last echo of motion, one last curve flung into the void saying, "We were here." You've wandered through the aftermath of a spiral galaxy's fall, seen stars flung into exile, black holes merge, arms unravel. But now, as you linger in the long tidal tail, a smaller shape catches your eye. It's not dramatic, not spinning, not sending out jets or glowing with the afterburn of a quasar. In fact, if you weren't paying attention, you might miss it entirely. A lumpy, irregular object, half the size of the debris it floats through, almost humble. This is a dwarf galaxy, and unlike the sprawling spiral you've been watching collapse, this one has already met its fate. You drift closer, and its story unfolds in silence. Dwarf galaxies are the unsung building blocks of the cosmos. Small, low in mass, often irregular in shape, and full of dark matter, they orbit larger galaxies like loyal satellites, or unlucky ones. Some are no bigger than a large globular cluster. Others, like the large and small Magellanic clouds around the Milky Way, are big enough to see with the naked eye from Earth's southern hemisphere. And unfortunately for them, they are very, very edible. You're watching one right now, what's left of it. It once orbited the spiral galaxy that's now an elliptical remnant. Maybe it danced around the outskirts, tugged slightly by the larger galaxy's tides. Maybe it passed too close, pulled in like a bug skimming the rim of a sink. Now it's being shredded. This process, called galactic cannibalism, is a slow-motion dismemberment. The dwarf galaxy's outer stars are already trailing behind it, stretched into a faint arc. Some of its inner clusters are tumbling out, peeled away by gravity. What's left is the core, still bound, still glowing, but definitely not going to make it much longer. You pass through the remains, and it feels eerily similar to the main spiral galaxy's collapse, just smaller, more intimate, like a scaled-down version of the same tragedy. Except this happens far more often. Historians still argue how many dwarf galaxies have been consumed by the Milky Way alone. Some estimates suggest dozens, maybe even hundreds over the past 10 billion years. Many leave behind stellar streams, faint rivers of stars that wind through the halo like stretch marks on a galactic belly. You see the same here. The shredded dwarf is leaving behind a glowing arc that may, in time, wrap around the new elliptical galaxy's halo, becoming part of its long, messy memory. And the weirdest part? Some of these dwarfs come pre-merged, meaning they were already composite systems, containing even smaller dwarf companions. The hierarchy of galactic consumption goes deep. Big galaxies eat small galaxies, which sometimes already swallowed smaller galaxies, and so on. You're looking at cosmic matryoshka dolls, each layer peeled away over eons. As you watch the dwarf galaxy crumble, you notice a curious sight. One of its globular clusters, a densely packed ball of ancient stars, is surviving the disruption. Unlike the rest of the dwarf, which is slowly being unbound, this cluster is holding together, and it's falling inward. That's something astronomers have observed and simulated. Dwarf galaxies donate globular clusters to the galaxies that consume them. Over time, these clusters join the host's halo population, like cosmic souvenirs of a forgotten system. The Milky Way's own Omega Centauri might be exactly that, a leftover core of a long-dead dwarf galaxy, still orbiting like it belongs. The one you're watching now? It may become just another object in the new galaxy's halo, but its stars will carry a different chemical fingerprint, a distinct pattern of metallicity that tells scientists, this one came from somewhere else. Because stars remember what galaxies forget. Another oddity drifts by, a bright, compact region, a nucleus, that might once have been the dwarf galaxy's core. These are especially resilient, denser than the rest of the system, sometimes containing their own intermediate mass black holes. They can survive long after the surrounding stars have been torn away. In fact, this is one proposed origin of some ultra-compact dwarf galaxies and even nuclear star clusters we see in big galaxies today. They're leftovers, fossils, cores of devoured dwarfs, now trapped forever in someone else's gravitational embrace. It's not always one-way destruction, though. Sometimes dwarf galaxies fight back. You drift outward and pass another small galaxy, less disrupted, still holding its shape. It's in orbit, yes, but it's not being shredded. Instead, it's triggering disruption. Its gravitational tug is stirring the outer halo, pulling streams of stars into motion, causing minor starbursts in leftover gas pockets. This is minor merger feedback, a less dramatic version of the chaos you've seen before, but one that adds turbulence to the outer edges of a galaxy, and occasionally kicks life back into otherwise dormant systems. Some even speculate that dwarf galaxies may have helped reignite low-level star formation in certain ellipticals, long after their cores had quieted. Historians still debate whether these dwarfs are pests or pollinators. You hover a moment, watching the dance between dwarf and host. The forces at play are slow, graceful, and deadly. Over billions of years, this small galaxy will likely fall in. It will lose its stars, its clusters, and finally its identity. The core may survive, the rest will fade. And so the cycle continues. The big eat the small leave scars, the remnants mix, and the galaxy evolves. In fact, some scientists believe most of the halo stars in large galaxies like the Milky Way came from consumed dwarfs. Every faint star, every oddly angled orbit, every chemically distinct population clues to past meals. Galactic cannibalism isn't a glitch. It's the engine of growth. And yes, sometimes it goes the other way. In extremely rare circumstances, a dwarf galaxy with a disproportionately large black hole might donate its singularity to the host, slightly shifting its core dynamics, or even nudging a sleeping black hole awake. Stranger things have happened. You move now between the streams of stripped stars, weaving through knots of unbound clusters and trailing arcs. Each one is a line in a cosmic script, handwritten, stretched, and slowly fading. They won't last forever. Over time, the stars will disperse. The arcs will fade into the galactic halo. The origin stories will be forgotten. But for now, they shine. Quietly. And you realize something simple but profound. This isn't the aftermath of a galaxy falling into a black hole. This is the universe at work. Every falling dwarf, every stripped tail, every flung star. A process, not a punishment. Out here, in the quiet dark beyond the galactic wreckage, it's easy to forget that this entire cosmic drama isn't unique. The stars you've watched fall, the gas stripped away, the spiral shredded and consumed by the central black hole. This story? It's not over. It's scheduled to happen again, to us. Yes, our very own Milky Way is patiently ticking toward its own dramatic destiny. An unavoidable rendezvous with the Andromeda Galaxy, our closest large neighbor in the cosmic suburbs. And you're not watching it happen right now, but you could be in a way. The scene you've just observed, the tidal tails, the black hole mergers, the ghost arms floating through space. It's a sneak preview of the show our galaxy is already set to star in. You float back now, as if stepping out of a dream, and look across space and time toward the familiar shape of the Milky Way. It's a lovely spiral, still structured, still full of star-forming regions and long, curling arms. And beyond it, Andromeda, bigger, also spiral, moving toward us at over 100 kilometers per second. They're coming for each other. And when they collide, it will be a slow-motion apocalypse lasting billions of years. You've seen the trailer already. The outer stars will be the first to feel it. Nudged by the approaching halo of the other galaxy, tidal forces will stretch, then fracture the spiral structure, gas clouds will compress, and then starbursts. Yes, just like the one you saw earlier, the last flare of star formation before the cores merge. Scientists expect the Milky Way-Andromeda merger to trigger a dramatic wave of new stars. For a brief time, both galaxies will blaze brighter than they ever have, as their gas collides and compresses under enormous pressure. But then comes the quenching. The black holes at the center of each galaxy, Sagittarius a star in the Milky Way, and Andromeda's central singularity, will spiral toward one another, and eventually they'll merge, exactly like the monster you saw formed in that previous galaxy. Historians and current astrophysicists with time on their hands and simulation software still argue over the exact fate of the resulting galaxy, but the best models suggest that it will become something new. Not a spiral, not quite an elliptical, but a hybrid structure often referred to by the delightfully sci-fi name, Milkomeda. That's right. Our future galaxy already has a nickname. Milkomeda won't have spiral arms. Its gas will mostly be gone, but it will be huge, swollen from the combined stars, bigger than either parent, and likely home to a single merged supermassive black hole at its core. And yes, that black hole will be bigger, much bigger. Every black hole merger adds to the mass of the central singularity, and this one is no different. Sagittarius A star is already about 4 million solar masses. Andromeda's is over 100 million. When they merge, the resulting black hole could tip into the hundreds of millions of solar masses, warping space for thousands of light years around. You pause now, imagining what that will feel like. Our solar system? It's not at risk of falling in. We're far enough out that we'll likely be flung into a new orbit, perhaps even tossed out into a long elliptical path around the new galactic core, or maybe exiled entirely. It's a cosmic lottery. Some stars win by staying in safe, stable orbits. Others are jettisoned, transformed into intergalactic wanderers, just like the ones you saw earlier. Our sun could become one of them. Earth, still clinging to its star, drifting quietly through empty space with no galaxy to call home. A weird thought. If you were watching from the edge of a nearby galaxy, this entire merger would look slow, elegant. First, a blur of motion as the halos touched, then twin galaxies spiraling into each other, arms warping and twisting, cores igniting, tails forming, and then, over billions of years, all that shape, all that order, dissolving. Some simulations suggest that Milkomeda will resemble the kinds of giant elliptical galaxies you see at the centers of galaxy clusters. Massive, round, structureless, and filled with aging stars. Not dead exactly, just quiet. It's humbling. We often think of the Milky Way as home, as permanent, but in the grand scheme, it's already halfway through its own story arc. The collision with Andromeda is expected in about 4 billion years, right around the time the Sun is entering its final stages of life. So, in a weird twist of symmetry, the Sun may die just as the galaxy begins its next transformation. You float back to the scene you just witnessed, the spiral galaxy consumed by a black hole, star by star, tail by tail. It looked distant, alien, but it's really just a preview. Our future, the fate of our star, our planet, everything. A reminder, galaxies aren't static. They grow, they feed, they merge, and they fall. Even the pretty ones. One fringe theory, and let's be honest, this one is more speculative than the rest, suggests that the very existence of supermassive black holes is responsible for the uniformity of elliptical galaxies. That over time, as mergers pile up and black holes grow, all galaxies trend towards sameness. Like the universe sanding down the sharp edges of its structures into quiet, round forms. A kind of cosmic entropy, the end of variety, the long, slow fade into uniformity. You leave the thought hanging as you pass once more through a stream of old stars, stars once organized into lovely arms, now scattered in slow motion. Somewhere, in a different galaxy, a distant observer is watching a red smudge with a faint tail and wondering what happened. You know, you've seen it, and you'll see it again. Because in this universe, every galaxy is on the menu. You drift now through the universe like a leaf caught on a gentle breeze, not tethered to one galaxy anymore, not bound to the scene of destruction you've just left behind. The remnants of the once proud spiral are far behind you. Its black hole is full, its stars are dimming, its motion has slowed, but nothing is ever truly over. Not in space. Because here's the most uncomfortable truth in all this cosmic carnage. Nothing is wasted. A galaxy may fall into a black hole. It may be torn apart, its stars scattered, its gas flung outward, its arms stretched and broken and erased. But none of it, not one atom, actually disappears. What you've been watching is not destruction. It's cosmic recycling. You pass now through some of the material that was ejected earlier, high-energy plasma pushed out by the black hole's jets. It's traveled thousands of light years since then, carving holes in the interstellar medium, triggering shockwaves in pockets of leftover gas. It's chaotic, messy, and it just might be starting something new. Because here's the twist. While the black hole sterilized its own galaxy, the energy it expelled might be fertilizing the space between galaxies. It's entirely possible that the jets, winds, and shockwaves from one galaxy's collapse will ignite star formation in another. You've seen this in some galaxy clusters, jets from one black hole lighting up the outskirts of a neighbor. So that doomed galaxy? It's still giving something to the universe, not out of kindness, just because physics. Even the tidal tails you floated through are on the move. They'll loop around the galaxy for eons, yes, but some of their stars will be pulled back in. Others will find their way into the halos of neighboring systems. And a few, lucky or unlucky, depending on how you see it, will end up as part of intergalactic stellar populations. These are real. We've observed stars drifting through space with no galaxy to call home. They're not flung with high speeds like hypervelocity stars. They're just there. Casual, forgotten, but still shining. Like dandelion seeds on a breeze, looking for soil. They may end up caught by another galaxy's gravity, or not. Either way, they're not wasted. You pass now through a different kind of structure, a thin, shimmering cloud of hot gas, remnants of the black hole's outflow. It's full of heavy elements: carbon, oxygen, iron, magnesium. You might remember these from the periodic table. But here, they're the ashes of stars. Every heavy element in the universe, every atom in your body heavier than helium, was born in stars and flung outward by death. Supernovae, neutron star mergers, the violent endings of luminous things. And now, even galaxy-scale deaths are doing the same. You're floating in cosmic compost, and someday, somewhere, it will collapse again, pulled together by a tiny gravitational nudge. Maybe it'll form a new star, maybe a new planet. Maybe someone else will stand on that planet and look up and wonder where it all came from. And the answer will be from something that once fell into a black hole. Historians and theorists, and let's be honest, philosophers with degrees in physics, still argue whether this process can go on forever. Can the universe truly recycle all its matter endlessly? Or is it a downward spiral, a slow burn toward heat death, where all energy spreads out too far, too thin, too cold to do anything useful? It depends who you ask. But for now, there's still plenty of life in the system. You float past a rogue molecular cloud, tiny but dense enough to be interesting. It's cooling, slowly. But the conditions are right. With a little help, it might collapse, might spark, might give birth to a new generation of stars. It could be a recycled spiral fragment, or a piece of a dwarf galaxy shredded long ago. Or maybe it was ejected by the very galaxy you watched die. Because galaxies don't vanish, they rearrange. Even their black holes aren't final. The singularity left behind by the merger you witnessed may lie dormant for eons, yes. But should another galaxy come too close, it will wake again, feed again, emit again, and the cycle continues. You pass now into a region between galaxies, once thought to be truly empty, now known to be full of the cosmic web. Long filaments of dark matter and gas, spanning the gaps between clusters. Most of the universe's mass isn't in galaxies. It's here, in these quiet places, where gravity works slowly and patiently. And even here, the influence of fallen galaxies is felt. Stripped gas enriches these filaments. Rogue stars light them faintly. Even black holes may drift through, kicked out of galactic centers by uneven gravitational wave emissions. We call these wandering black holes, and they may be more common than we thought. Massive, invisible nomads traveling in silence. You spot one now, nothing more than a distortion in the star field. No disk, no glow, just space curving a little too sharply. It's not feeding now, it may never again. But it exists, left behind by someone else's fall. Because again, nothing is wasted. You drift away, and for a moment, you can see the arc of it all. Not just the fall of one galaxy, but the ongoing remix of the cosmos. Matter flowing from one structure to another, stars born from the wreckage of stars, planets forming from the leftovers of collisions, black holes merging, jetting, fading, and then waiting. The universe is the most efficient recycler you'll ever meet. Your galaxy falls into a black hole? No problem. Its stars become someone else's sky. Its gas becomes someone else's sun. Its black hole might one day light up a quasar for someone else's telescope. And the light from its final starburst may travel for 1 billion years to reach a planet where some creature looks up and wonders what happened, and smiles at the mystery. You begin to fade now, drifting farther from the scene, wrapped in the comfort of a cosmic truth. The universe never stops using its parts, not even the broken ones. And so, here you are, on the final leg of this strange and stellar journey, drifting beyond where galaxies are still colliding, where tales are still unraveling, and where black holes, like silent royalty, sit fat and full after centuries of feeding. There's something eerie about this distance. You're outside the blast radius, outside the gravitational well, beyond the glowing clouds and curled-up streams of X-stars. What surrounds you now is the cosmic background hum, not in sound, of course, but in presence. The whisper of the universe, not in action, but in reflection. And that's where we find our final question. What becomes of the black hole? Because it's still there, just sitting, massive, spinning, quiet. At the center of a once spiral, now lumpy elliptical, this monstrous object, born from stellar collapse, grown fat on star clusters and gas clouds, finally merged with another of its kind, is technically at rest. But black holes don't retire. They wait. Even in its so-called dormant phase, the supermassive black hole at the center of the wrecked galaxy is anything but passive. It continues to curve the space around it, influence star orbits for thousands of light years, and maintain its gravitational rule like a king in a crumbling castle. Quiet, yes, but not irrelevant. You hover just far enough to avoid the trap, but close enough to feel its pull in the equations. Distances behave differently here. Time is slightly off. Light from background stars bends around it in elegant arcs, gravitational lensing in action. If someone were watching from the other side, they might see multiple distorted images of you, warped like funhouse reflections. Except the funhouse is a bottomless pit with perfect memory. But that memory? It's controversial. Physicists still argue, sometimes loudly, over whether black holes truly erase information. The famous information paradox pits general relativity, which says everything falls in and vanishes, against quantum mechanics, which says information is never destroyed. Some believe that the surface area of a black hole, the event horizon, stores all the data about what's fallen in. Others argue it's hidden in Hawking radiation, the slow quantum leaking of particles over cosmic time. And yes, technically, even this supermassive beast will evaporate. Eventually. Given enough time, say a few quintillion years, it will radiate away mass via Hawking radiation. Not that you'd see it. The radiation is faint beyond faint. The process is so slow that if the universe were a person, it would have to wait longer than its own lifespan to see a black hole lose weight. But it will happen. If the universe lasts long enough, every black hole will eventually shrink, and the final fate of this once great devourer? A tiny pop, a whisper of heat, a cosmic sigh, and then nothing. The ultimate quietus. Before that, though, this black hole might get another chance. A new galaxy might wander too close. A dwarf might spiral in. A stream of cold gas, left over from some nearby merger, might sneak inward and reignite the accretion disk. The dormant phase could end. That's the real reason black holes aren't dead ends. They're conditional endings, more like pauses. You float farther now, outside even the halo of the elliptical remnant. Behind you, a glowing, aging sphere of stars slowly settling into a long retirement. Ahead of you, the web of the universe, stretching in strands and filaments, dotted with galaxies just like the one you left behind. Some are spirals, still spinning, still proud. Some are ellipticals, their arms long gone. Some are in progress, mid-collision, trails of stars winding like smoke between them. Maybe you're seeing the beginning of another fall, another black hole merger, another transformation, another cosmic rebirth. It's all one process, one long, tangled life cycle. Galaxies are born. They grow, spin, form stars, they collide, they fall into black holes, they shed arms, they become someone else's fuel, they fade, and occasionally they leave behind echoes, star streams, rogue clusters, orphan black holes drifting through intergalactic space. The universe, for all its appetite, is strangely sentimental. It keeps everything, even the broken pieces. That's why, as you turn one last time to glance at the galaxy you watched fall into itself, there's no sorrow, just gravity and memory. It looks small now, distant, quiet, a pale ellipse in the dark, holding on to the last heat of a long-forgotten starburst. But somewhere inside that glow, stars are still orbiting, clusters are still spinning, and the black hole still waits. You pass a lone hypervelocity star on your way out, an ancient red dwarf flung by the merger recoil, still glowing, still moving. It doesn't know where it's going. It just knows it's going. Forward. Always. Just like the universe. Because even when a galaxy falls into a black hole, even when the structure collapses and the arms unravel and the center glows itself dim, nothing ever truly ends. It just drifts onward, and so do you. The journey slows now. You've seen the heart of a galaxy unravel, watched its arms torn away, its stars consumed, its black holes merge and settle into silence. You drifted through the aftermath, through clouds of heated gas, glowing tails of starlight, and the slow choreography of chaos rearranged into stillness. And now, the lights are low, the stars are distant. The universe hums softly, like the last vibration of a string after the final note fades. Out here, in the deep, there's no up or down. Just motion without urgency, just time without markers. The stars don't rush, the galaxies don't grieve. Everything just continues, slowly shifting, cooling, fading, forming, collapsing again perhaps. But not tonight. Tonight, everything holds still. You've been to the edge of a black hole, to the fall of a galaxy, to the birth of a new remnant forged in fire and gravity. And still, space gives no judgment. Only room and quiet. You can let go of questions for now. The spirals, the jets, the screaming matter. Those are stories for when you're awake again. Out here, you're weightless, peaceful, a single breath in the long exhale of the cosmos. So, take one of your own. Let the drift carry you. And if your dreams take you back to that broken galaxy, falling into a monster, let them. Let the quiet pull you into sleep, as gently as light curves around a black hole's edge. You're part of the story now, too. The stars will still be here when you wake.